Hello, here we will discuss about probability theory. So for probability theory, before knowing about its definitions, we need to understand basic terminology and basic terms of probability and what are the definitions, what are the examples for that. So there are some terms like what is the meaning of trial and what is the meaning of events, what is the meaning of exhaustive events, and how will we define favorable events, and how will define mutually exclusive events, and what do you understand about equally likely events, and how will define independent events. So all the terminology here will define with help of the separate examples. That would be the that would give the basic clarities about probability theories. So now we'll discuss about trial and event. So here we need to understand what is the meaning of trial and what is the meaning of event. So the experiment, whenever we are going to begin any experiment, is known as a trial, and after experiment whatever outcomes will get, that is known as events or cases. So in other way we can say trial refers to trial refers to experiment and event refers to outcome. So this is 2 points we need to understand. Let's have example, then we'll get more clarity. Like for example, throwing of a die. I hope you all are aware about the die. So throwing of a die is a trial. Once we are throwing a die, that refers to trial, and getting the outcome, it may be one, it may be two, or up to three, four, five, six. So whatever outcomes we are getting, that is known as the event. And other examples, if tossing a coin, if we are tossing a coin, so that process known as the trial, and getting a head or tail, that is known as the event. So this is the basic meaning of the trial and event. And other way we can say drawing cards means playing cards. Here we are talking about the playing cards. So drawing two cards from a pack of well shuffled cards in a trial and getting a king and a queen are events. So this is the basic definition about trial and events with examples. Now one another term which is known as the exhaustive events. So what do you understand about exhaustive events? Let's have a definition. The total number of possible outcomes in any trial is known as exhaustive events or exhaustive cases. Like for example, once we are talking the tossing a coin, so there is a chance we may get head or tail. So there are two choices, two options. So this is known as the exhaustive events. It's one head or two tail. This is the trial. And if we are getting the head, so if we are getting the head, so this is the head. So this is the outcome. So our probability would be 1 divided by 2. So our this is known as the favorable case, and this is known as the exhaustive events. So this is the way to get the uh, answer. So now we'll have one example for exhaustive events. So we can say same as I said, in a tossing of a coin, there are two exhaustive cases, that is head and tail. The possibility of the coin standing on an edge being ignored. If maybe coin may stand, in that condition it will be ignored. And second examples, like throwing up a die, there are 6 exhaustive cases since any one of the 6 phases 1, 2, 3 up to 6 may come uppermost. So this is the example of the exhaustive cases. And same as I said for playing cards, drawing 2 cards from a pack of cards, the exhaustive number of cases would be 52 CT. So C represents here combination formula 52 CT. So we need to understand how to calculate 52 C2, since 2 cards can be drawn out of 52 cards, that is 52 C. So as we know, N C NCR, that's formula we know, we can calculate it n factorial and divided by, as we know, r factorial. This is the factorial notations, don't be confused here, like this way we write, and within a bracket n minus r factorial. So this is the way we can find out the total number of exhaustive cases. Now we have another uh, terms which is known as the favorable events or favorable cases. So how we'll define it? So we can define the number of cases favorable to an event in a trial is the number of outcomes which entail the happening of the events. As I said, tossing the coin, there is the total exhaustive number, head and tail. And so if you are getting the tail in favor, so that would be your favorable cases. So tail or head. So we need to understand what is the favorable case, what is the exhaustive case. Now let's have one example. In a drawing, a well suffered playing cards from a pack of cards, the number of cases favorable to drawing of an ace is 4, for drawing of a spade is 13, for drawing of red cards is a 26. So this is the example. Now one more example, like throwing up 2 dice. The number of cases favorable are getting the sum of 5. If simultaneously we are tossing 2 coins, so what is the sum of the? So first dice may get 1, second 4, 4 are 1, 2 are 3, 3 are 4. So that means there are 4 favorable cases which we need to understand. Now on another term, we need to understand the definition of what is the mutually exclusive events. So let's have one definition, like events are said to be mutually exclusive or incompatible if the happening of any one of the precludes the happening of all the others, if no two or more of them can happen simultaneously in the same trial. So this is the basic definition of the mutually exclusive events, but we have an example, you will get the clarity about mutually exclusive. So like for example, in a throwing a die, all the 6 faces numbered 1, 2, 6 up to 6 are mutually exclusive. Since if any one of these faces comes, the possibilities of others in the same trial is ruled out. Let's we have example. Similarly, same in a tossing a coin, the events head and tail are mutually exclusive. Means once we are tossing a coins, we may get head or tail. So that is known as the mutually exclusive. We have one another example, we'll get more clarity, like in a study of consumer behavior, an analyst classifies the people who enter clothing store according to sex or gender, we can say male or female, and according to age we have categorized here under 28 or 28 and over. So the two events are classifications here, male and female. we can say are mutually exclusive, since any given person would be classified in one category or the other, either male or female. Similarly, the events under 28 and 28 and over are also mutually exclusive. However, the events male and under 28 are not mutually exclusive because a randomly chosen person could have both characteristics, that may be male and that may be under 28. So this is the basic example of the mutually exclusive events. Now one another term which is known as the equally likely events. So what is the meaning of equally likely events? Let's understand. Like outcomes of a trial are said to be equally likely if taking into consideration all the events evidences. There is no reason to expect one in preference to the others. For example, in tossing an unbiased or uniform coin, head or tail are equally likely events. Means tossing a head. So there are 50% 1 by 2 chance for getting head, or 1 by 2 chance are getting tail. So this is the meaning of equally likely. In throwing an unbiased die, all the 6 faces are equally likely to come. And one another terms we need to understand what is the independent events. So independent events, we can say several events are said to be independent if the happening or non-happening of an event is not affected by the supplementary knowledge concerning the occurrence of any number of the remaining events. So we can say, for example, in tossing an unbiased coin, the event of getting a head in the second, third, and subsequent throws. So these are the independent. Like for example, your education means once we are getting educations, so learning the knowledge skills, that is the independent events we can say, are income levels, whatever earning persons earning, that is known as independent events. Now we have to define the probability. What is the meaning of probability and how we'll calculate the probability, that is the important point. So here point is define the probability. If a trial results in n exhaustive, mutually exclusive, and equally likely cases. See, whatever terminology we have defined already, all the terms is going to consider in the definition of the probability, and m of them are favorable to the happening of an event e, then the probability p of happening of event E is given by, we can calculate. This is the formula of the probability. So probability of happening event A is equal to favorable number of cases divided by total exhaustive number of cases. Already we have defined what is the favorable number of cases and exhaustive number of cases. So notational we can divide m divided by n as defined in the statements. So this is the basic definition and formula of the probability. When we have example, and probability is also called, there is the different nomenclature. So once we'll read the book, so we can find out this terminology. So it is called somewhere mathematical probability, or it is also known as classical probability, or a priori probabilities. So one example we can have the clarity about the probabilities. So if in a well shuffled deck of cards, that means playing cards we are talking, which contains four aces, and 48 other cards. As we know, in playing cards, there are total 52 cards. So the probability of an ace A being obtained on a single draw is, so we can calculate here probability of event A divided by number of favorable cases divided by number of exhaustive cases. So here favorable cases is given 4, exhaustive number as I said total 52. We can solve it 1 by 13 is the probability. So as we know, probability always lies between 0 to 1. If we are calculating the probability and we are getting out of this range, so that means we are doing something wrong in our calculation. So these are the terms we need to understand. What is the trial, what is the event, what is the uh, favorable cases, what is the exhaustive cases, and what is the mutually exclusive cases, what is the independent events, equally likely events. All the terminology we need to understand, then it would be easier for us to calculate the probabilities. Thank you.